One of the important things to remember when we are working with transformations is that it doesn't matter which type of function we're working with. We could talk about a linear function, a quadratic, an absolute value function. It doesn't matter. Those transformations work the same way no matter what. So when we start graphing, which is what we're going to do in this first example here, remember what the parent function looks like and think about what transformations happen. So this is example 1A of graphing transformations. And I'm going to show you two different strategies that you could use to graph a transformation. Okay, so again, it doesn't matter which function you're working with. So let's use our absolute value function here. And let's graph our function f of x equals the absolute value of x minus 3. All right, first of all, let's think about what this parent function is going to look like. It's absolute value, so it's that V shape with that bottom of the V at the origin 0, 0. Now this minus 3, it's on the inside. The inside means it's going to affect our graph horizontally. And the inside also, our transformations, whenever we have something on the inside, our transformations are the opposite of what we think. So this minus 3 on the inside is really going to go to the right 3. All right, so this brings us to our graph. And we have two different strategies that you can use to graph a transformation. And our first strategy is to graph our parent function. Okay, so we'll graph our parent function, which we said was absolute value. You can look back at what we just wrote down here for our parent function for the table of values. Or if you remember, the absolute value is a V with the bottom at the origin, and each side has a slope of 1 or negative 1 over here. Hitting all these points along the way. All right, so again, first strategy, we graph our parent function, and then we'll graph our transformed function. I like to use a different color if I'm using this strategy. So you can see that this was our original. And if we take each of those points and move it right 3, that's going to give us our f of x equals the absolute value of x minus 3. So take each point, translate right 3. All right, so in this guy, notice how we're keeping the same shape. Instead of having our V with the bottom at the point 0, 0, we still have our V, the bottom point is just moved to the right. So this line in the blue, our absolute value here, is our final answer. Okay, that's one strategy for graphing a transformation. The second strategy is to use a table of values. And it's up to you which strategy you are going to like better. Personally, I like using this table of values. And last year, I think most people liked the table of values also. But again, it's totally up to you. So table of values, we would start off by making the table of values for our parent function. So on that last little bit, we saw our table of values here. -2, -1, 0, 1, 2. And then our y values, 2, 1, 0, 1, 2. Okay, so the table of values, it might seem a little bit more complicated here, but when we start throwing some more transformations in together, you might like this one better. But anyway, when we see this table of values, we need to think about, okay, we know our transformation is right 3. Is that going to affect our x or our y values? Well, it's affecting your x values since it's going left and right. Well, if it's moving our graph to the right 3, how are our x values going to change? If we want to move our graph right 3, that means my x values are going to get larger. So I add 3 to each x value. Once you do that, the numbers we have left tell us the points, the ordered pairs that we need to graph. So the point 1, 2 is here. The point 2, 1, 3, 0, 4, 1, and 5, 2. All of our points are there. All right, so again, doesn't matter which strategy you use. Personally, I like this using a table of values better, especially when we get to the more complicated situations. There